Okay, good morning. Today, for pre-calculus, I'm going to be looking at inverse trig functions. So the first thing and one of the main ideas you got to get here is that, we've already talked about inverse sine, inverse cosine, inverse tangent. Those are the same as the arc sine, arc cosine, and arc tangent. So these two things here, arc sine and inverse sine, with the -1 being there, are exactly the same thing, just written differently, okay? So with that said, what I'm looking at when I say the inverse sine of x equals y, I'm saying what's the value, x is the value and y is the angle, okay? So when I say the angle, it's always in radians, okay? So if I was looking at something like this particular problem where it says y equals the inverse sine of 1/2, what that really means is I'm looking for, which angle gives me the inverse sine of 1/2, okay? Or find the angle y whose sine is 1/2, okay? So for this one, if I'm looking over here at this, I'm looking at the 1/2, and I know that sine is opposite over hypotenuse. Which angle is opposite the 1? And so if I'm looking here, opposite the 1 is the 30. There's the 1, there's the 30. So 30 degrees is my answer in degrees. However, they want my answer to be in radians, so pi over 6 is my answer because that's radians. So we've gotten to that point where I need you to learn some values. These are the values that you should know. Pi over 6 is 30 degrees. If I double that, I get pi over 3, which is 60 degrees. 30 doubled. I'm cutting the denominator in half, which is what I do when I double something. 45 degrees and 90 degrees. So if I know 45 degrees, I can find 90 degrees by doubling it. 45 degrees is pi over 4. Pi over 4 times 2 is pi over 2, just like 1/2 is twice 1/4. And if I know 90 degrees, I can find 180, 270, and 360, which are the other values you should know. Pi is 180, 3 pi over 2 is 270, and 2 pi is 360. So these are values that you're going to need to know for this particular chapter. All right. The other thing is, in the last section, when I was doing a problem like this, we talked about there being two answers because the sign is positive in the first quadrant and the second quadrant, so there'd be two answers in that range. In this particular chapter, we're just going to be looking at the primary ones, which are the, for the sine and the tangent, they go from pi over 2 to negative pi over 2, which in other words is the first and fourth quadrants. So if my answer is positive, it will be in the first quadrant, and if it's negative, it will be in the fourth quadrant. Those are pretty straightforward, I think. Cosine is the oddball. Cosine goes between 0 and pi, okay? So if it's positive, it's in the first quadrant, but if it's negative, that's the one that's in the second quadrant. And the reason for that is because, the cosine is positive in the first and fourth quadrants, so we can't have we got to have the positive and the negative parts of the answer. So anyway, that is something you should become familiar with too. You should know that. All right. Next. So these special right triangles. We're going to evaluate these with no calculator. Okay. So arc sine, same as inverse sine. I'm looking for what's the angle that gives me whose sine is the square root of 3 over 2. So remembering that the sine is the opposite over the hypotenuse, which angle is opposite the square root of 3. So here's the square root of 3, which means that 60 degrees is opposite it, okay? So I am going to have 60 degrees as my answer. However, it's got to be in radians, which means that's the same as pi over 3. Number 2, arctangent is 1, which means which angle. Remember, tangent is opposite over adjacent. And I can always go 1 over 1, which means I'm looking over here at this triangle. So which angle is opposite the 1? Well, that's 45. They're both opposite the 1. which means 45 degrees is my answer. However, it's got to be in radians. 45 degrees in radians is pi over 4. Number 3, arc cosine, square root of 3 over 2. Cosine is adjacent over hypotenuse. So the adjacent to the square root of 3, remember adjacent means next to. So the 30 is next to the square root of 3. So my answer would be 30 degrees, but once again, it's got to be in radians. 30 degrees is pi over 6. Next one. This one, they reduced the radical on us, which isn't a big deal. This is the same as 1 over the square root of 3. Okay? What they did was they took that and they multiplied it by the square root of 3 over the square root of 3 to get rid of the radical in the denominator. And when you do that, you get square root of 3 over 3. So this one's easier to work with, so I usually use that. Okay? Remembering that tangent is also opposite over adjacent. So which one has the opposite, which angle is opposite the 1 and adjacent to the square root of 3? Opposite the 1, that's here. The 30 degrees is opposite the 1. So 30 degrees is my answer, but we got to put it into radians. 30 degrees in radians is pi over 6. There's my answer. Number 5, inverse cosine of 1/2. Remembering that the cosine is the adjacent over the hypotenuse. And adjacent over hypotenuse, we said adjacent to the 1, which would be that one. Adjacent to the 1 means next to, 60 degrees. So 60 degrees in radians is pi over 3. And that's my answer. Okay, arc cosine of 0. This one's a little different. When I see those zeros and ones, that's often the unit circle. Okay, now if it's tangent of 1, that's a little different because tangents of 1, it gets you to the 45, 45, 90 triangle. But this one's not. This is cosine, which means I'm going back to my unit circle, remembering these are the coordinates of those points with zeros and ones. And cosine is the x-coordinate, so I'm looking for, what's the x-coordinate that gets me 0? Well, there's 2 of them. It's at the top and the bottom there. But I got to remember, so with cosine, it only goes from here to here between 0 and 180, which means it can't be the bottom of the circle. So it's going to be this one up here, which is 90 degrees, which is the same as pi over 2. And that, my friends, is the answer. Okay, next one. Arc sine of 0. All right, so same idea, back to sine, the unit circle. 0 and sine. So sine's the y-coordinate. So I want the y's. Which one gives me 0? Remembering that sine goes between, is in quadrants 1 and 4. Which means that's my answer, which is at 0 degrees. Okay, that's the answer, it's 0. So sine of 0 is 0. Number 8. So this one's arc cosine. Cosine's negative, which means, remember my answer is going to go between here and here for cosine. So I know it's going to be in the second quadrant. Okay, now I need to know what the reference angle is when I get 1/2. So remembering the cosine, forget the negative for a minute. Cosine's adjacent over hypotenuse. So which one's adjacent to the 1 and has the hypotenuse of 2? I know it's going to be the 30, 60, 90. Adjacent to the 1 is the 60 degrees. So 60 degrees is my reference angle. So if I take my triangle, I go like this. If this is 60 degrees, then how many degrees is that? That would be 180 minus 60, which is 120. But now I need to turn it into radians. So you could always, if if you've forgotten this stuff, you can multiply by pi over 180 and reduce. Or you could remember that 60 is half of 120. 60 is pi over 3, which means 2 pi over 3 would be twice that. Okay. Write that down. 60 degrees equals pi over 3. Therefore, 120 is 2 times that, 2 pi over 3. All right, next one. Arc tangent. So I know that my tangent's positive here, negative there, so I'm going to be in the fourth quadrant. So I'm going to end up with a negative angle. That'll be my angle. So square root of 3, and you can always put that over 1. So tangent is opposite over adjacent. So I'm looking for which angle is opposite the square root of 3. Back up to that triangle, over and over again. Opposite the square root of 3 will be the 60 degrees, okay? So 60 degrees is my reference angle. So 60 degrees is my reference angle. And which means I'm down here. So if that's 60 degrees, then I'm going all the way around to there. So it's going to be a negative angle. It's going to go down to there because we set up at the top here that the tangent, it's not going to be all the way around the circle almost. It's going to be negative 60 degrees, which is the same as negative pi over 3. And that's the answer. And the reason is because back up at the top here, I said that the tangent goes between pi over 2 and negative pi over 2. So I'm going to have positive and negative numbers over there, okay, for the angle. All right, so back over here. Arc sine is negative pi square root of 2 over 2. So once again, they reduce that denominator. This is the same as 1 over the square root of 2. Make it negative, okay? Multiply top and bottom by square root of 2. Which means the sine is positive here, negative here. So once again, I'm going to have a negative angle. It's going to be my answer. That's going to be what my answer will get me. So I'm looking for the sine is opposite over the hypotenuse, which one is opposite the 1, and the hypotenuse of the square root of 2, which gives me 45 degrees. Where is it? Yeah, opposite the 1 and hypotenuse square root of 2. So 45 degrees is my answer. However, that's got to be in radians, which is negative pi over 4. Okay? Great. Yeah, 2 more of that kind, and then a couple more coming up after that. This one, cosine is negative. So once again, cosine is the oddball, where it's here and here. So I know my answer is going to be over here. So that's not a negative angle over there. We try to go the way that's shortest from the x-axis, which means it's here. But that's why we're having negative angles, because it's the shortest distance to the x-axis there, which would give you a negative angle. All right. Anyway. Oops. Just erase something. Cosine, adjacent over hypotenuse. Which one's adjacent to the square root of 3? If I go back up to my triangles, adjacent to the square root of 3 is 30. So that's going to be my reference angle is 30 degrees. But remember, this is the oddball, so this is going to be 30, which means my angle is actually 180 minus 30, or 150. So if I take 30 degrees, which is pi over 6, and I multiply that times 5, that will get me, like 30 times 5 is 150. So this would give me 5 pi over 6. Or you could think about, that this is pi over 6. Halfway around the circle is pi, which is, 6 pi over 6. 6 divided by 6 is 1. So 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. Okay. Number 12. Arc cosine of square root of 2 over 2. Negative, of course. Which means two things. I know the cosine is positive here, negative there. So once again, I'm going to be in that second quadrant. And cosine, they reduce the radical on us, which is the same as 1 over the square root of 2. And cosine is adjacent over hypotenuse, which means I'm looking for which one's adjacent to the 1, and hypotenuse is square root of 2. Adjacent to the 1 would be that one with the square root of 2. So 45 degrees is my reference. So that means this is 45. So 45 degrees is pi over 4, which means this is going to be 180 minus 45 is 135. 135 is 45 times 3, which is 3 pi over 4. That's one way to think about it. You could also go 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. Anyway, that's the answer. I should circle that. Okay. Okay, 13. These are nice and easy. You have to think about what these are asking you for. So with this question, they're asking for what's the angle whose sine is 1/2, which of course would give me 30 degrees, and then you take the sine of 30 degrees, which would give me 1/2. So that one like ends up right back where you started, kind of thing. Okay. So when you have the regular function in front, sine of the arc sine, you end up with whatever you had inside. Okay. So it's different if it's the arc sine first, but we'll get to that in a minute. So this time, once again, I got the cosine of the arc cosine, which means, you know, if it's whatever this is, that's going to be your answer, which in this case is 0.54, okay? You'd find what the angle is, then take the cosine of it. Those two counteract each other, and you end up with where you started. And the same thing for tangent. If I take, since it's regular tangent first, arc tangent second, that means that my answer is going to be negative 0.2. Okay, now these get different when you have the arc tangent first, because you know you can change around the angle. So I start on the inside with this one, and I'm looking at what is the tangent of 11 pi over 6, which means, you know, 11 pi over 6 is 12 pi over 6 would be 2 pi, which means my reference angle is pi over 6 there. But you know, I got to keep in mind this is a negative angle. Which angle gives me that? That's what the answer is since the tangent is negative down there, that's in that fourth quadrant. That's why I get a negative answer here. Okay, so that's my answer for that one. 17, arc sine. Once again, I got the arc in the front, so I could end up with a positive or negative answer because the angle can be different, right, depending on where that is. 5 pi over 3, this is 6 pi over 3 would be 2 pi. 6 over 3. Which means I go almost all the way around to here. And remembering the sign is positive here and negative there, that means this is 1 pi over 3, which will give me my answer. All right, so those are those couple weird kind of problems. Let's see. I got one more here. The arc cosine of the cosine of 3 pi over 2. So 3 pi over 2 is here. So the cosine of that, remember the cosine is the x coordinate which is 0, -1. So that would be 0. And what is which angle gives me that? And I am right back to but remember, this has to be between here and here for the cosine, which means the other one is the counterpoint, which would be 0, 1. So that one also has an x-coordinate of 0, which means that's the one I want, because 90 degrees, which is pi over 2. Because the cosine is the one that goes between quadrants 1 and 2. Okay. 19. Arc sine of the sine of 5 pi. So first let's find out what the sine of 5 pi is. So here's 0, here's pi, which means if I go around to pi, and then that's 1 pi, 2 pi gets me back over here, 3 pi gets me there, and then if I go around again, I get 5 pi will hit me here. This would be 4 pi. So in other words, I went around the circle 2.5 times. Okay, pi is 180 degrees. So anyway, I land there. Okay, so what is? Remember, the sine is the y-coordinate, which means this is -1, 0. So that would be 0. And then I'm asking for what is the inverse sine or arc sine of 0, which would give me 0. I'm here. That's the x1. I don't have to move it. The sine goes between, these two quadrants here, which means that's my answer. Okay, that's the angle that gives me 0. Sine of 0 is 0. Okay. So next one, last two. This one, write theta as a function of x. So I need to get the theta alone, which means, the first thing I want to do is I want to write this as a function. Theta is the angle, x is opposite the theta, this is the adjacent. Opposite over adjacent is tangent. So if I went tangent of theta equals x over 5, that's a function. Now I want to get the theta alone, which means if I do the inverse tangent or the arctangent, either one, I can switch those two, right? Which means theta gets alone, and this could be the arctangent of the x over 5. And that is my answer, okay? Next one, this one. So theta, same directions. This is my opposite. This is the hypotenuse. So the function with opposite and hypotenuse in it is the sine. So the sine of theta equals 3x over x plus 2. Now once again, remember that if I do the arc sine or inverse sine, do arc sine of 3x over x plus 2, parentheses there, I need them around the whole fraction. This would either equals theta, okay? So there's my two answers, and now I got theta alone. Just like if I asked you to write, y as a function of x, you'd have y equals 2x plus 4, or whatever it is. If I asked you to write x as a function of y, you'd solve for x and write the rest of it with the y. All right, so anyway, that's the answer. That's all that I'm doing for today. Have a great evening, or wherever you're at, and talk to you all soon.